Okay, hi everyone, and welcome to the first real tutorial video in the Apollo tutorial series. And in this part of the tutorial, we will be looking at how we create an application description which Apollo can understand. So the outline going to be as follows. We first gonna have a look at the application which we want to get running in this overall tutorial series. So we're going to essentially see what the tutorial is about. After that, I'm going to be talking about Afcl, which is the domain-specific language which we use to describe the application in a way that Apollo understands, and about Apollo's workflow editor, which we use to generate these Afcl descriptions. Those first 2 points will be more or less the theoretical part where I just talk and show you things. And after that, we're going to have a walkthrough part where we basically will see how it looks like if you start out without having anything installed or anything on your computer, how you get the editor, how you get it to work, and how you would use it to create the workflow for the application we are looking at in the tutorial. And this workflow will essentially be the result of this part of the tutorial. So let's get started. Now, in this tutorial, what's overall about is about an application we create, and the application we are looking at will be something that encodes a given string using the Caesar cipher. So the Caesar cipher, you're probably familiar with that. It's one of the easiest ways of encoding documents. This was allegedly actually used by Romans. And how it works is your overall application, it will get two things. It will get a string, like any non-encoded string, for example, the word Apollo, and it will get a particular offset. For example, 2. And what it will then create, it will encode the string by basically taking each character and shifting it by this offset, by the specified offset to the right. So out of Apollo, we would get the CRQ and then Q word. You know, when you shift A by 2 to the right, it becomes C, P becomes R, and so on. Now, this is obviously a very simple application, and this is not really something where you would want to execute it in a distributed and parallelized way. We are mainly looking at it because it's relatively simple. We can implement all the steps ourselves in a very easy way. At the same time, it offers us the possibility to, on the one hand, distribute it into multiple parts, separate the application into multiple different parts, multiple tasks. And on the one hand, it also has a part which can be nicely parallelized. So how it will look in our case is that we define 3 so-called functions, and these functions are individual parts of the application. The first function will be the split, which takes the given string as input and it separates it into individual characters. So it will return an array or a collection of characters. The second function is shift. So this function will be executed in parallel once for each of the characters. It will get a character, it will get the offset value, and it will shift the input character by the provided offset value. And finally, we will have the assemble function. The assemble function will take the array or the collection of the shifted characters and create a string out of it again. That's essentially it. That's what we're going to be doing. And looking at this image, we can actually also talk about a distinction between 2 important concepts in case of Apollo, and that's the distinction between functions on the one hand and the workflow on the other. So functions, as you see here, are basically the parts of the application. Those are individual steps which constitute a part of what your application does, and each function takes some input and produces some output out of it. Now, the important thing when you work with Apollo is that Apollo doesn't really care about what a function does. So a function is seen as black box. It doesn't need any knowledge about what it does or what its requirements are and so on. It just needs to know how its input and its output looks. Because all that Apollo is doing is it coordinates the interaction between the functions. So it makes sure that the data flow and the control flow, which is required by your application, for example, in our case, the fact that our split takes place before the shift, the fact that the output of the split is distributed among multiple instances of the shift and so on. All these are data flow operations, and Apollo takes care of those. Now, in order to be able to take care of data and control flow, it of course needs to know how the data and control flow of your application looks like. And that is what you provided with the so-called workflow file. And this is the main focus of the tutorial we are looking at right now. Here we're going to see how you would create such a workflow description which Apollo can understand. Of course, we do also care about the functions. You also need to be able to specify what happens in each individual function, and that will be the focus of the next video, where we will see how we define them and how we deploy them on AWS or as a local Docker image. Okay, now back to the workflow file, which is our focus right now. So Apollo, in order to understand what the workflow says, how the data and control flow of the application looks like, needs it in a certain format. And this format is called Afcl. I think Afcl language is actually double because the L stands for the language, but this is a specific format. It's based on YAML, and it's a domain-specific language for the description of control and data flow of distributed applications. Now, the syntax and the constructs used in Afcl, they are described on an own website. So it's here. I will link it into the description of the video. I think you can have a look at it because you just see which concepts are there and how they are used. We have examples for all of it. The important thing is please just consider the schema 1.1 because the other one is outdated. And in fact, the 1.1 is also not super up to date. We have things like the switch in there, which we actually threw out by now. So practically, we are instead going to be working with the editor and not with directly implementing Afcl, because if you've worked with YAML files, this is pretty messy and very error prone. I think it's much cooler to work with the editor because it offers autocomplete features and suggestions, and it basically enforces a correct syntax of Afcl. It doesn't use Afcl directly, but you can automatically generate Afcl files out of that. And as the last entry here said, the Afcl editor is something that I had very little to do with the development. It was really heroically developed by two students of mine, by Chris Engelhardt and Jakob Mittelberger. And if you're wondering why I'm saying heroically, then you should try working with MPS. So MPS is a tool that the editor is based on. It's super cool because it lets you define domain-specific languages and editors for it. It's not so cool because it's super user unfriendly. So I really am super grateful to Chris and Jakob for doing all the work connected to the development of the editor. Okay, well, that essentially was the part where we were just talking about what we're going to do, and the rest of the video essentially is going to be the walkthrough. And it starts by the steps you need to get the editor running on your system. And after that, we're going to look how you then use it to define a workflow. So to that, we first go to the repository of the editor. I will also link that into the description. And there, when you just scroll through the README, you see here's a section on the tutorial. And this is what we're going to look like. You don't need to do the build process because the build process is all about actually adjusting the editor. For example, if you would want to add a new Afcl compound or something like that, we don't need that right now. We just look at the editor, the tutorial, and we click here. So the first thing we need to do is we need to actually download the editor. So those will be our first steps. We download it, we unzip it, and then we start it. So to download it, you click this link in the repo. There you have some zip files. This one is for Mac, this one is for Linux, and this one is for Windows. Now, in my case, I would need the one for Linux. I already downloaded and unzipped it just because it takes about 5 minutes so that we don't wait. And this is the directory I have it in. So this is just a temporary directory I created for the purpose. And this is how the content of this directory should look like when you have successfully downloaded and unzipped it. And now in the bin folder there, you have the file Afcl editor.sh. And if we just execute that, this will start up the editor. Now, this may take a little while. And in the meantime, I can basically show you what we're going to be doing. If we just go back here, we are just going to continue going through this tutorial. Okay, this is very weird what GitHub's doing there. Ah, come on, GitHub. Okay. Huh. Okay, I will probably cut that part out. So let's just wait. And then we go to this part where we launch it, and then we start following the instructions coming from here. Okay, so we jumped a little bit into the future there because opening up the editor takes a little bit of time, but now we're here. Now, when I open it, I already have a project open because I worked with that before. This is not what you're gonna see. You're gonna see something similar to what we get when we go to a new project. And here we can just say, okay, project 6, whatever, we can let that name there. And then we will say that we have the Caesar solution as a solution. Then we hit OK. And we want to open it in the same window. And here we go. That's basically the thing. And now, honestly, I forget myself the steps that we need to do. So it's easiest to just follow what the README of the tutorial says. So here we are now. We have created the project. So now we need to generate a new solution. That is a new model. So we go here, we right-click, new and model. Now the model name, we can let it like that and go OK. And now we need in the used languages, we need to add one. And the one we are interested in is Afcl. Hit OK here and OK there. And that is nearly it. The last thing we do is just we say we create a new workflow. Now this one does not have a name yet, so we can call it Caesar. Okay. And that essentially is all you need to set up the editor. So from here on out, we can actually work with that. So I will switch here to the presentation mode because we can now work exclusively within that editor. And we go to the next step of the tutorial. So we are done with all of that. And the next thing is now we actually start to define our application. And the first thing we do is we need to define our input. So we know that essentially in this Caesar Cypher application, what we get at the start is a string, which is our original string, and an offset, which will be a number. So let's see how we define that. So for that, we go to input. You can just click it. And the thing is, in this editor, you don't have to type that much. The thing you do most of the time is just using autocomplete. So if we hit that right here, we see, okay, it's a data input. That's what we want to do. And then we can say that we have one input, which will be called original, because it's the original string we get. And then it will be a string. And then we can say that it's Apollo. So that is the first input. And the second input can have the name offset. and it will be a number, and we can make it the number 2. Now, you see, this is correct. The editor accepts it. The important thing is what we've defined here is we defined 2 constant inputs. So we just defined variables that we can reference. One is called original and always has the value Apollo. The other one is called offset and always has the value 2. This is probably not exactly what we want. What we would want instead is we would want to say that we want to have an input which is taken from an input file, because that would make us more flexible. And if you look into the tutorial, you basically see exactly this description here in this input category. So what we did here is we defined constants, but what we want instead is we want to define input variables, which are read from a JSON file, and this happens in this format. So what we need to do instead, let's just delete this one and this one. We say it's still a data input. We still want to call it original, but we have to make a colon and say, or a double colon, I think, and say this will be a string, and this will be taken from JSON and will be called original. So that means we will have an input file, and this input file will specify, this will be a JSON file, and it will have an entry called original, and from there we will take a string, and this string will be used as input of the workflow. And we want to do a similar thing for our offset variable. So we say the offset is going to be a number, and this similarly will be taken from JSON, and there it will be called offset. Okay, that is that. So at this point we are basically done with this. And the next step we want to do is we want to define our first function, the split function, which will get the original word and give us the collection. I mean, you see here, this is not correct. The split function doesn't really get the 2. I mainly did this to avoid clutter, because the 2 actually goes to the shift function, which then would have a lot of errors, but we will do it correctly in the workflow. So what we're defining now is the body. So we go inside, and here you can just, again, hit autocomplete, and we want to define a function statement. The name basically doesn't really matter. We can call it split. The type is a different thing. So the name and the type are not the same thing. The type of a function basically determines on which resources it can be implemented. This will probably become more clear when we talk about resources in the next video. But you can imagine if you, for example, had the situation that your application would contain multiple additions, you would define them in the workflow by multiple different functions, because they would have different inputs and outputs. But what you would be doing inside would be the same addition. So those would be functions with different names, but with the same type. But since we have only one function of each type here, it doesn't really matter, and we can call it split as well. Okay, now we need to define what our split function gets as input. We go autocomplete. It's a loop data input. It doesn't matter. You can just choose it. The name doesn't really matter, so I would pick something which is expressive, which tells you what is done with that, and that would be the original string in this case. And now the question is, where do we get it from? And we get it from the workflow input. So we select the workflow input name, and the reference, you see it gives us already directly only the 2 variables that we defined, and we want the original one. And the other thing is the output, and that will be an output. We can also give it an expressive name, and that will be the character array, and the type will be array. So this is exactly Apollo's perspective. It basically knows what does this function get as input, what does the output look like, and basically where do we get the input from. And we get it from up there. Okay, with that, we've defined the split function. The next step is to defining the shift. Now, the important part is this shift happens in parallel. And as the input, each of these shift function gets one of the entries of the collection, which we just defined. So in fact, this is a for each. And this is exactly what we're going to define next. So we go autocomplete. We have this for each entry. We can call it for each shift. And then we have to define the input of the for each. And the input of the for each is the collection which is used to be parallelized. So for this, you may want to consider the Afcl website. There we have extended explanation how these compounds work, and we also have examples. But here at this point, we just say, okay, so our input, let's just call it the iterator, and we will be taking it from the split function, and it will be its output, which is the character array. So that's what we basically, that's the collection for each of whose elements we are going to be executing the body of the for each compound that we define. Now we need the body. That will be more easy. That will be just the function which we need to define. So we can call it shift. Again, with the type, we can just call it shift again. And now to the input of it will be the original character. And here we have to define the input of the for each compound as our input, because we have to distinguish between this output of the split function, which is a collection, and the output, so to say, of the for each input, which are individual entries. Again, if that's confusing, have a look at the Afcl documentation, and if it's still confusing, just write me an email, and I will try to improve this explanation. Now, the shift function actually needs an additional input, and that is the offset. And this is a situation where each of the functions will need the same offset, so we will reference something outside the parallel for, and that we just do by saying offset. And we want something from the input of the workflow, and this is the offset. So this is the input of our shift function, and the output will be the shifted character, and that will be a string. Okay. The other thing, the last thing that we have to define here is the output of our for each construct, and the output is again going to be a collection. So what this parallel for thing does, it gets a collection, it makes sure that it executes its body for each of the individual entries, and in the end it assembles the outputs of the individual bodies, and that's what we have to define here. The name will be the shifted character array, and the scope, it's going to take it from the shift operation, and it's going to be the summary of those outputs of the functions executed in parallel. That's basically the most complicated part of the workflow definition. And the one before last thing we have to do is we have to assemble it again. That's again easy. That's just a different function. So we can again say this is a function called assemble. The type will also be assemble. Its input gonna be the shifted character array, and it's gonna take it from the for each shift as its output, and what it will give us at the end is the encoded string, and it's obviously going to be a string. And finally, the the last thing we have to define is the overall output of the workflow. So we have to define it extra what we kind of want from the execution of the workflow. And in this case, it will basically be again the encoded string, which is produced by the assemble function. Yeah. And that is pretty much it. So you see the editor doesn't show any errors. In fact, as long as you don't start like typing around wildly, but it basically mostly really doesn't let you do anything wrong, which is, in my opinion, a pretty cool thing. And with that, we are nearly done. So at this point, I can leave the presentation mode. The last thing you want to do is you want to take this file you defined in the editor, and you wanna convert it to an actual Afcl description, and you do that by right-clicking here and selecting Preview Generated Text. And what it will do is it will generate this workflow for you. And this is essentially an Afcl file which you can directly use as input for Apollo. And with this, Apollo will understand how the functions are connected and how it's supposed to execute them. And in fact, exactly this YAML file, which describes the workflow, is the result of our tutorial. And this is what you find if you go into the tutorial, look into part 1, which we are doing right now, and there you see the result. This is how your Caesar workflow will look like. So if you generated one doing this tutorial, you can get that one and compare them. The names may be different, but the structure will be the same. Okay, that's basically it. I hope you found it interesting. I hope you found the editor cool. I really like it. Again, thanks a lot to Chris and Jakob. And in the next video, we're gonna be looking at how we actually define these functions and how we deploy them on AWS and Docker. See you then.